Hello everyone. So today we are solving a question of JEE ADV 2012. So let's read our question. So they're given a thin uniform rod which is pivoted at O and it is rotating with the horizontal plane with constant angular speed omega. As shown in the figure, at time t equal to 0, a small insect starts from O or means the origin and moves with the constant speed with speed v with respect to rod towards the other end and reaches the end of the rod at I equal to t. The angular speed of the system remains omega throughout. The magnitude of the torque on the system about as the function of time is best represented by which plot? Okay, so we have to predict which graph will be the answer here. So let's imagine first our condition here. Sorry for that. Let's suppose this is our origin here and our rod is something like this. Our rod is of length L here and they're given an ant here. Okay, so let's assume this is an ant which is moving with a constant velocity and they are together like rotating with a angular velocity of omega here. Okay, and they are saying that the angular velocity is always omega here. See, if no torque was acting, so what would have happened here? Since initially let's write what is the moment of inertia initial when the ant was at the origin. So initial moment of inertia was nothing but ml square by 3. But as ant is, sorry for that, ml square by 3 here. But as ant is moving, so it is also adding a moment of inertia of m of, let's suppose it covers r distance. So mr square. Every time it is moving with some, let's suppose it is here. So let's say this distance r. So it is adding a more moment of inertia. That's why we can not say that there is no torque applied, but a torque will be applied here. And we have to predict its graph or the function as a time here. Okay. So let me write the definition of torque here. What is torque? So torque is change, like said as the rate of change of angular momentum. I will like give you the analogy of force here. Since we know that what is force, you must have seen that this definition only mdv by dt. But there is also a term which has been neglected so many times, that is uh, v dm by dt. Just like that, just like this is very much similar as Newton's law. Torque is also equal to I times d omega by dt plus omega times di by dt. We know that generally in the questions the moment of inertia doesn't change because the material is the same. That's why we ignore this part. Here what can we can see that omega is never changing with the time. So we can say that this term is equal to 0 here. So what is torque? It is equal to omega times di by dt. Okay, that is the change of moment of inertia with respect to the time here. So let's write what is the moment of inertia at any time t. Okay, so we know that the rod is still like it is not changing or any difference in the structure. So its moment of inertia will be always will be equal to ml square by 3. What will be the moment of inertia added by the ant here? It will be nothing but, since it is moving with an constant velocity of v, so it will cover a distance of vt, and we know that the moment of inertia of the ant will be nothing but ml square. Okay, so mvt square. So we can write it as mv square t square. Now we want di, this is nothing but equal to di as a function of t. We want di by dt, which will be nothing but, if we differentiate this, so we will get mv square 2 times t. This is our function here. So we can say that basically omega is also a constant. So omega times di by dt is equal to k times t here. So it means it will give a linear graph with a zero intercept, which is matching to, I think, our option B here. Okay, you can correctly see here the option B is matching here. So our final answer is nothing but B here. Thank you, everyone.